So here we have a compound inequality. There are two given, and we're going to solve them both for x and then graph the solution. First thing that we need to notice is that this says and. So this is a two-step inequality. So the first thing I'm going to do is add 10 to both sides. Then I'm going to divide both sides by -2. And then I get 8 is less than x. Well, there are two conditions under which you would flip the inequality, and one of them's occurred here. If I multiply or divide both sides by a negative number, that flips the inequality. And in order to graph this, I would want to flip this again. So this would become x on the left is greater than 8. For this one over here, I'm going to add 10 to both sides. And then I'm again going to divide both sides by -2, which will flip the inequality. And then it'll again flip the inequality when I move the x to the left so I can graph it. Now, in order to do this, I'm going to have x is less than 10. And notice it doesn't have the equals part, so it's not less than or equal to. So I'm going to graph x is less than 10. So now when we're graphing this, one thing that we need to note is since this has and, it has to satisfy both of the inequalities at the same time. So we can write this as a single compound inequality. And it's saying that x is bigger than 8. So if I have 8 and x is bigger than 8, so I needed this one, and then x is less than 10, so I can write this with the x in the middle. And now to graph this, I have 8 and 10. And since we don't have the equal part for less than or equal for either one of these are both going to be open interval. So I start off by making open dots, and then it's going to be in between the two. So this graph is an open interval between 8 and 10. In this example, we'll notice that the two inequalities are connected with the word or. So I'm going to solve the left inequality by adding 10 to both sides of the inequality sign. Then I'm going to divide both sides by -5, which will flip the inequality. For the second inequality, I'm going to solve it first by adding 10 to both sides of the inequality symbol. Then I'm going to divide both sides by -5, which will flip the inequality. Now I'm going to graph the result. So x is less than 6 is an open interval at 6 because the inequality does not include 6. There's no equal. And it's every number that's smaller than 6. And then for x is greater than or equal to 12, that'll be a closed interval going to the right. As you can see, any number that satisfies either one of these inequalities will be an answer to the set. If this was the word and, well, there would be no number that would satisfy both of the two inequalities. Let's look at another example. This is a special case. Notice that for these two inequalities that they're separated by the word and, which means that the answer that satisfies one must also satisfy the other, so it's more restrictive. So we start off by solving these. So for the left one, first thing I do is add 1 to both sides. Then I divide both sides by 2. And for the right inequality, I subtract 4 from both sides. Then I divide both sides by 3. And I get x is greater than 2. Now I'm going to graph both. Now for this graph, if I was to graph this, I want all the x's that are bigger than 2, so it would be over here and it would be an open dot. But since this says and, it must satisfy both of these. And this one says x is less than or equal to -1, so it would go this way and it would be a closed dot. And since there are no solutions that satisfy both inequalities, the answer to this one is just the empty set. This example is really interesting because it's another special case. So let's solve them and look at what's so special on the graph. So for the left inequality, first I'll subtract 2 from both sides. And next I'll divide both sides by 3. And in order to graph that, I'm going to have to flip that For the inequality on the right, I want to first subtract 2 from both sides. Next, I want to divide both sides by 3. Our answer is 12 is greater than or equal to x, but I want to flip that so that the x is on the left so I can graph it. Now, looking at the graph of the first inequality, x is greater than or equal to 10, is a closed dot and goes to the right from 10. And the second one is x is less than or equal to 12, is a closed dot and goes to the left of 12. Now, since this is OR, my answers don't have to satisfy both of the inequalities, just one of them. Therefore, any number that's on this number line going to minus infinity and positive infinity is part of the answer. So what we do is the answer for this one is the set of all real numbers, and this is the notation for that. Now, sometimes you're given an inequality where it's already connected like this, and it's just as fast. It's just there's a method, you do both of them at the same time. And since I need to get x by itself in the middle, what I'm going to do is I'm going to subtract 4 from each of these terms here, which is going to give me 15 is less than or equal to minus 5x, which is less than 50. Now, since I have to get the x by itself, I'm going to have to divide each of these terms by the same number, and this needs to be positive x. So I'll divide each of them by minus 5. Now, finally, I'll get minus 3 is less than or equal to x, which is less than minus 10. Now, since I had divided each of these by minus 5, I have to flip both of these inequalities. Now, when I graph it, I'll draw the line and I'll mark both minus 3 and minus 10 on the line. Now, from here, this is going to be, the minus 3 is bigger than the x. If I was to separate these, it would be x is less than minus 3. I'll write that up here. X is less than or equal to minus 3. And this one over here is as written, so it's x is greater than minus 10. So now x is less than or equal to minus 3 is a closed dot going to the left. And the second inequality is x is greater than minus 10. So when I have x is greater than minus 10, it's an open dot starting from minus 10 and it goes to the right. Now, since these were connected, this is an AND statement. And what we're looking for is only what's in between from here to here. So this is a half open interval going from minus 10 to minus 3. And it does not use any of this over here or over here. So this is the solution set that's going to be in here, because this is the same as having an AND when they're connected like this.